Well, kids, here we are, Monday morning, March 23rd, 2020, beginning of our second week of digital learning. Today, we are going to be learning about heat transfer in the atmosphere. But before we do that, this page right here on my desktop, the atmosphere, the layers of the atmosphere, this worksheet is due today. It should be, you should take a screenshot of this when you have it completed. You should upload it to Google Classroom. I'm going to open that up right now. It's called Layers of the Atmosphere worksheet. So you're going to take a screenshot. You're going to attach that screenshot and you're going to dump it into this folder here, Layers of the Atmosphere worksheet. Again, due today. We've been working on it for a while, so make sure that you get that in. All right. In our notes, I'm going to scroll back here a little bit here. We're going to touch on this stuff that's right at the beginning of section 2, energy transfer in the atmosphere. And when you look in the book, and we're starting section 2 now, right here, energy transfer in the atmosphere. The first thing to understand is that almost all of the energy that we use here on planet Earth comes from the sun. There is some that comes from internal heat from inside the Earth, and also a little bit of radioactive decay creates some heat, but almost all the energy that's used comes from the sun. And this first picture here in the bottom of 435 describes what happens to that energy as it's coming from the sun. And you can see various percents of that energy are used in different ways. For example, 6% of the sun's energy that heads towards planet Earth hits the atmosphere and it's reflected right back into space. Doesn't heat the Earth, doesn't heat the water, none of it. Furthermore, 25% of the sun's energy that's headed towards planet Earth is reflected from the clouds. Hits the clouds, there's ice and water droplets in those clouds. That's what a cloud is. We'll get to that down the road. Reflects it right back into space. 15% of the sun's energy, when it hits the atmosphere, is absorbed by the atmosphere. So when you were doing that worksheet assignment and we did the temperature in each of the various layers, that has a lot to do with the gases that are in that layer. Some gases trap heat. And when you saw those spikes in temperature, that is a great example of how we can tell that. For instance, the upper part of the stratosphere here, a lot of the ozone layer, it absorbs heat from the sun. So, moving back to where we were at here. Sorry. We have the last 4%, 4% of the sun's energy that hits the Earth's surface and bounces right back up. Doesn't warm the surface much. We don't really get any benefit off of it whatsoever. Mostly that's hitting ice. Ice is a reflector of the sun's energy. Water is an absorber. So when you add up 6 and 4 is 10 and 25 is 35 plus 15%, 50%, which is in these four numbers of the sun's energy is not used at the surface of the Earth. And 50% then does get used, energy that's absorbed by the Earth's surface. Now, that energy itself that actually is absorbed here at the Earth's surface is transferred to other things in 3 different ways. And that's really the point of the lesson today. And those 3 things are right here on 436. Radiation, conduction, and convection. So that's going to be the bulk of the rest of my video lesson today, the differences between those 3 things. And you're familiar with at least 2 of them, and maybe all 3 of them you should be pretty familiar with. The first way that heat is transferred within the Earth's atmosphere is by radiation. And radiation, as you look here in the definition, is energy that is transferred in the form of rays or waves. Rays or waves. So, the most obvious example that you're used to is heat energy from the sun being transferred to your body. If you go lay out at the pool this summer or out in your yard on a nice sunny day and you hold still and you feel that heat from the sun, it's reaching you through rays and waves or radiation. All right. We have lots of other examples you can see up here in this picture. Radiation warms the surface of your hand if you hold it, above a fire, above a candle, above a burner. Of course, I am not recommending you that you do that. We're not trying to get hurt here, but that is an example of how heat is transferred through radiation, through rays and waves. The second type is conduction. And conduction, when you look at the definition, the transfer of energy that occurs when molecules bump into one another. So first of all, heat is always transferred from the hot thing to the colder thing. All right. So in this case, we have something that's warm or hot, something that has heat, and its molecules bump into something that is less hot. A great example of this would be back to this burner up here, which again, we are not recommending this. But if you've ever accidentally touched a hot burner, that was conduction. The heat from the coils, uh, those molecules, they bumped into the molecules in your hand, and that heat was transferred through those molecules. So when molecules bump into one another, heat is transferred by conduction. Same thing as if you had an ice cube and you put it in your hand. The heat from your hand is conducted to the ice cube because the molecules of your hand are touching the molecules of the ice, and that heat is transferred, and you know what will happen to that ice cube. Of course, it will melt. The third way that energy is transferred in the atmosphere is convection. This definition is not great. It says it's a transfer of heat by the flow of material. Here's how I always describe convection, and we've talked about this already this year. Hot stuff rises, cold stuff sinks. That is the gist of convection. In our classroom, we talked about the heat coming out of the register. It goes to the top of the ceiling where it's the warmest. It moves across the ceiling, and then it sinks down as it cools at the other end. And so you get this loop, this convection current. Hot stuff rises, cold stuff sinks. That also happens in the atmosphere. Let's see, we get some nice hot sunny summer days and it heats up the cement around Village Pool. First of all, the air that's touching the cement is warmed by conduction. Those air molecules bump into the cement molecules and heat is transferred in that way. But that heat, hot stuff rises. So that warm air rises up into the atmosphere where it eventually, and we're going to learn this in the next chapter, it cools down because we saw in our temperature graph that it gets colder the higher we go up. It eventually cools off, it condenses and forms clouds. So convection, hot stuff rises, cold stuff sinks. Now, that is about as far as I want to go with new material today. Those three concepts: radiation, transfer of energy through rays and waves; conduction, transfer of energy when molecules bump into one another; and convection, hot stuff rises, cold stuff sinks, or the flow of material, as your book calls it. Now, there is some work to be done with this. There will be a couple of days. This will be due on Wednesday. But when you look in your packet, and we're going to have to move forward here quite a bit in the packet. This page right here, transfer of heat, says in the space below, for each type of heat transfer, draw a picture that illustrates the transfer of heat. Label the heat source, label the direction of heat transfer, which means where's the hot thing, the heat's going from what to what, and then describe in words what's taking place in the diagram. For instance, if it was me laying at the pool, I would say that heat is being transferred from the sun to my body through rays and waves. Pretty simple. Now, your book, which you may use these pictures if you understand these pictures. This is the picture that describes radiation. This is convection, and this is conduction. All right, you can use those pictures. You do need to label the heat source and the direction of heat transfer, as I said before. So that assignment, the drawing of those three things and labeling of those three things is going to be due Wednesday. All right. In the meantime, you are going to need to respond in Google Classroom. I will have 3 or 4 questions, multiple choice, just like they have been. You have to respond to those questions every day. That's how I'm taking attendance, so to speak, to see who's following the lessons, who's doing what I need them to be doing. So make sure that you keep up with that work in Google Classroom. I will send you email reminders if I don't see those things in there, but they should be completed every day. After you watch this 10-minute video, go on, answer those 3 or 4 questions, work on the 3 drawings sometime between now and Wednesday, and then Wednesday we'll upload those pictures. All right. So to wrap up for today, again, layers of the atmosphere worksheet that needs to be uploaded, put into here today. If you haven't done the ozone layer quote unquote quiz, the 5 questions in there, you need to make sure you get that completed. The layers of the atmosphere quiz, if you haven't got that done, there's just a few people that haven't, get that done and turned into me. If you have questions, by the way, there are directions here in our notes, and I need to get back here. See this message right here. If you haven't had a chance to work out Google Hangouts yet, follow these directions. If it's not on your iPad, you just need to do a hard restart, and that should help take care of the problem. That's the best way to get a hold of me for questions. You can contact me through there at any time. Typically 8:45 to 9:45 is the time in the morning, and 1 to 2 in the afternoon, but I'll get back to you just about any time. All right, so if you have questions, contact me that way. If you need to see me, we could try Google Meets. That's not something that I've done yet with students, but if you'd like to try it, we could also do Google Meets. And that would be a video lesson, I guess, or question and answer session. So make sure you do the things that I need you to do for today. Hopefully you understand radiation, conduction, and convection a little bit better now than you did before. And I hope you have a great rest of your day. And we will talk to you soon. Bye.